Okay, this video shows you how to fit the one-way normal model using JMP. So the example used here is the railroad rails data. We have an X or a covariate or a factor called rail. So this factor indicates which group the response is belonging to. So for so the time is just the excessive travel time of the mechanical wave in the rails. And for rail 1, we have 3 measurements, 55, 53, and 54. And these 3 are belonging to the first group indicated by the rail factor. Okay, same for the others. And to do that, you can do analyze and fit y by x. And you choose x factor and time is the response. Okay, there you got this. This is the scatter plot of time against the rail. And what you can do here is that you can make the quantile by actual. This gives you a normal quantile plot of this data. And with this normal quantile plot, you can check whether the normal assumption is met and whether the standard deviations of all these 6 groups are approximately the same. That is to check the equal variance assumption. Okay, and for the other things, you can use another fit. You can use a fit model. And in the fit model, you again choose time as the y and the rail to the construct model effects box. And then click on run. And in this output, first you can find the residual by predicted plot. You can use this to check whether the residuals are evenly distributed around the y equals 0 line. And this plot can also be used to check whether the variances for all these groups are approximately the same or not. And in the summary of fit, you can find the R squared and the root mean square error. So this is just the pooled sample standard deviation. And in the analysis of variance table, this is just an ANOVA table, and this table is used to do the F test we introduced in the lecture video. And in the right, you can find the table of least squares mean. So this table gives you the estimates of the 6 means. You can use these means to do the confidence interval. And there is also standard error of the mean. So the standard error of the mean is actually just the pooled sample standard deviation divided by the square root of ni. Just the same as so if you just want to do the confidence interval for the single mean, for example, in the first example we showed in the lecture video, if you only want to construct a confidence interval for mu1, then you can use 54 plus or minus the t quantile times the standard error. So this is actually just in the railroad example. This is just an SP divided by the square root of 1/3. Okay. And yeah, that's all for the ANOVA model output. And one thing you need to check is that if you fit the model for this factor variable, in this case it's real, you need to make sure that in the column info, the modeling type is nominal. So by default, it's always continuous, but you need to change it to be nominal. Okay. And oh yeah, there is one more thing. So we can use it. We can use a jump output to make a normal QQ plot of the residuals. So to get that plot, you need to use the fit model. So in the fit model, Y is the response and the real is the current model effects. Then you click on the red triangle here, and in the row diagnostic, you want to get the residual by normal quantile plot. So this gives you the normal QQ plot of the residuals, and this plot also is also used to check the normal assumptions in the one-way ANOVA model. Okay, that's all for this video.